This is ELC131, Circuit Analysis 1, and in this video we will look at the source conversion theorem. Now, the source conversion theorem allows us to take a voltage source and its series resistance connected to two terminals shown as A and B in Figure 1 and convert it to a constant current source and a parallel resistance connected to terminals A and B. And we can also, with the source conversion theorem, convert the current source and its parallel resistance to a voltage source and a series resistance. So the source conversion theorem allows us to convert these sources and resistances from one configuration to another. Now, to convert a voltage source to a current source, we follow these steps. We place a short between the terminals A and B, and we find the current flow through those terminals A and B. And this is our constant current source, labeled IS. Then we open the circuit between the terminals A and B and find the resistance between those two terminals with the voltage source replaced by a short. And this is the value of our parallel resistance, RP. Then we place IS and RP in parallel with the terminals A and B, and this is our equivalent constant current source. Then we replace the component or components that were originally connected to the terminals A and B. Now, the steps we take to convert a current source to a voltage source are: 1. We open the circuit across the terminals A and B and find the voltage across those terminals. This is the constant voltage source, Vs. Then we find the resistance between the terminals A and B with the current source replaced by an open circuit. This is the series resistance, Rs. Then we place Vs and Rs in series with the terminals A and B, and this is our equivalent constant voltage source. Then we replace the component or components that were originally connected to those terminals A and B. Hopefully you are seeing some similarities with our voltage source and series resistance to the Thevenin equivalent circuit and the current source and its parallel resistance to the Norton circuit. So let's look at an example of the source conversion theorem. We're going to convert Vs and Rs in a circuit of Figure 1 to a current source and a parallel resistor. Then we'll use this constant current source to determine or calculate the current through resistor RL. So note that the voltage source and its series resistance connect to the two terminals A and B. So we're going to take everything to the left of A and B, Vs and R1, and convert it to a current source, Is, and a parallel resistor, or a parallel resistance, Rp. So the first step is to place a short between the terminals A and B, and then find the current through the terminals A and B, and this is our constant current source, Is. Now you note that when I place the short from A to B, that all the current's going to flow through this short circuit. No current will flow through resistor R2 or resistor RL. So with the terminals shorted, the source current, the constant current source, is Vs divided by R1, which is 5.45 milliamps. Then we open the circuit between terminals A and B and find the resistance between those two terminals with the voltage source replaced by a short circuit. And certainly you can see in the circuit of figure 3 that the resistance from A to B is only R1. So the value of Rp, the parallel resistance, is equal to R1, 2.2 k ohms. Then Is and Rp are connected in parallel with those terminals A and B, and we replace the component or components that were originally connected to those terminals. So the circuit of figure 4 shows our equivalent constant current source circuit. Now again, understand that R2 and RL cannot tell the difference between the circuit of figure 4 and the circuit of figure 1. That with respect to components that are to the right of terminals A and B, this current source and parallel resistance is equivalent to the voltage source and series resistance in figure 1. So looking at the circuit of figure 4, we can calculate the current through the load resistor using the current divider formula. IRL equals I source times R total over R load. 5.45 milliamps times 991 ohms over 10 k ohms gives us a load current of 540 microamps. Now, in our series of videos on circuit analysis theorems, we have covered the Thevenin's theorem, Norton's theorem, the superposition theorem, and now the source conversion theorem. Understand that there are many more circuit analysis theorems available for analyzing these electrical circuits. They would include nodal analysis, mesh current analysis, branch current analysis, loop current analysis, Millman's theorem, and others. However, when the application of nodal analysis, mesh current analysis, branch current analysis, loop analysis, those analysis theorems yield a series of simultaneous equations that have to be solved to find our circuit values, be them currents or voltages. And not that dealing with simultaneous equations is all that difficult. In this class, I will present only those theorems that do not require the solution or through the analysis of simultaneous equations to yield our voltage and current values.